Hi guys, welcome back to our discussion on infinite series. So in this video, we will discuss about the ratio and the root test. Okay, before we discuss the definition of the ratio test and example, so let us first define or discuss the objectives of this lesson. So number one, use the ratio test to determine whether a series converge or diverge. Then use the root test to determine whether a given series converge or diverge. And the last one is to review the test for convergence and divergence of an infinite series. Okay, let us now define the ratio test. So according to this theorem, let the summation of u sub k be a series with positive terms, and suppose that rho is equal to the limits of u sub k plus 1 over u sub k as k approaches positive infinity. So letter A, if the value of rho is less than 1, then we can say that the series converge. And then letter B, if rho is greater than 1 or rho is equal to positive infinity, then the series diverge. But in letter C, if rho is equal to 1, then we can say that the series may converge or diverge, so that another test must be tried. Like, for example, suppose you are asked to use the ratio test to determine whether the series converge. And if the test is inconclusive, then say so. So in this example, now you're given the summation of 3 to the k over k factorial, where k is from 1 to infinity. So to show that this series is convergent or divergent, so we need to find the value of rho. Okay, so from the definition, rho is the limits of u sub k plus 1 over u sub k as k approaches positive infinity. Okay, but you can also rewrite this as product instead of quotient. So you have the limits of u sub k plus 1 times 1 over u sub k as k approaches positive infinity. But what is u sub k plus 1? Okay, if u sub k is 3 to the k over k factorial, then u sub k plus 1 is 3 raised to k plus 1 all over k plus 1 factorial. Okay, multiplied by 1 over u sub k. So if this is your u sub k, then 1 over u sub k is the reciprocal. You can write this as k factorial over over 3 raised to k. Okay, as k approaches positive infinity. Okay, but 3 raised to k plus 1 can be factored as 3 raised to k times 3 divided by, while k plus 1 factorial can be written as k plus 1 times k factorial. Okay, multiplied by k factorial all over 3 raised to k as k approaches positive infinity. But because k factorial is common, so you can cancel this out, same as 3 to the k. So we can now define rho as the limits of 3 over k plus 1 as k approaches positive infinity. So in this case, if we replace k here by infinity, so the value of rho is 3 over infinity plus 1. But 3 over infinity plus 1 is infinity, and 3 over infinity is equal to 0. So any number divided by infinity is equal to 0. Okay, so therefore we can conclude that since the value of rho is 0 and this is less than 1, we can therefore conclude that the series converge. Okay, another example, given the series summation of 1 over 5k, where k is from 1 to positive infinity. So to use the ratio test, we need to evaluate the limits of u sub k plus 1 times 1 over u sub k as k approaches positive infinity. But what is u sub k plus 1? If this is u sub k, then u sub k plus 1 is obtained by replacing all the k variable here by k plus 1. So thus, 1 over 5k can be written as 1 over 5 times, replace k by k plus 1. So you have k plus 1 times 1 over u sub k. So if this is your u sub k, 1 over u sub k is the reciprocal of 1 over 5k, which is 5k all over 1. And as you can see, because 5 is common, so we cancel this out. So we can now reduce this to k over k plus 1. And recall in calculus that to evaluate the limits of a rational function, we divide each of the term, both the numerator and denominator, by k with the highest exponent. So we divide each term, both the numerator and denominator, by k. So k over k is 1 all over k divided by k is 1 plus 1 over k as k approaches positive infinity. So to evaluate this, we replace all the k variable by infinity. So we get rho is 1 over 1 plus 1 over infinity. But 1 over infinity is 0. So therefore, rho is equal to 1. And if we can recall from the definition, if the value of rho is equal to 1, or if the limits of u sub k plus 1 over u sub k as k approaches positive infinity is 1, then we can therefore conclude that the test is inconclusive. Okay, from the previous slide, using ratio test, we found out that this series is inconclusive, meaning we don't know yet whether this series is convergent or divergent. So because this is inconclusive, you can use other tests to check the convergence or divergence of the given series. Okay, from this example, we can observe that because this constant 1 over 5 is a constant coefficient, so you can factor this out. So you can write this as 1 over 5 times the summation of 1 over k, where k is from 1 to positive infinity. But recall that this series is a harmonic series. Recall that the standard form is the summation of 1 over n, where n is from 1 to positive infinity. And recall that harmonic series is a divergent series. So because this is divergent and this is a harmonic series, so we can therefore conclude that 1 over 5 times summation of 1 over k is also a diverging series. So we can conclude therefore that since summation of 1 over k is a harmonic series, which is a diverging series, so therefore the summation of 1 over 5k, where k is from, this should be from 1 to positive infinity, is also a diverging series. So this should be from 1 to positive infinity. So in summary, the ratio test states that given the summation of u sub k, which is a series with positive terms, and suppose that rho is the limits of u sub k plus 1 all over u sub k as k approaches positive infinity. So if the value of rho is less than 1, the series converge. But if rho is greater than 1 or positive infinity, the series diverge. And if rho is equal to 1, the series may converge or diverge, so that the another test must be tried.